So in the previous video, we saw that the norm, the restriction of the norm to the units of z adjoin root 2 to the 2 as 1 minus 1 is a group homomorphism, right? So let's actually look at the image. Okay, wait, so let's actually put some sort of bar on it or something. I don't know, what could we do to show this unit? Maybe let's put 1 here to show that this is some kind of restriction to the units, right? So n1. So the image with respect to n1 of 1, so this is all the elements that map to 1. All the elements. So in the previous video we showed that any unit would map to 1 or minus 1. Is it true that any element that has norm 1 is a unit? So if it has norm, if some element, let's say x element of z root 2, if the norm of x is equal to 1, is it the case that it is a unit? Maybe. Maybe it is, but it's not clear. Might need proof. But so the question. So if maybe it is clear. Let me just check. So so if you have x, so if the norm is 1, does there exist? The question is, does there exist a y such that x y is equal to 1? It's hard to say. So I won't try to do that. Maybe I'll think about it and see if we can answer it in the next video. But in this case, let's look at the image of get n goes to 1. So because 1 is a multiplicative identity, without really saying anything else, well, it's clear as we're talking about n1. The image of 1 is actually just the kernel. Sorry. So what we want is pre-image, right? N inverse of 1. So why do we care about n inverse of 1? So first of all, why am I looking at n inverse of 1? N inverse of 1 is all the elements that map to 1. All the elements in U, x elements of U, so such that norm of x is equal to 1. Well, precisely because we want to find these things, right? That's what we care about. Because of the Pell equations. And in this case, this is some, maybe this is not all of them, but we get like a nice bunch of them of a certain form. And this is equal to the kernel of n1, right? Because this is a group homomorphism and 1 is the identity element. And by some theorems of group homomorphisms, this kernel of n is actually a subgroup of U. Subgroup of U. Subgroup. Okay. So that means that at least if the solutions of this equation are units the solutions of this equation are units. Actually, no. Sorry, the solutions of this are clearly units, right? So if x norm of x is 1, then x bar times x equals 1. So we just, oh my god, I'm so sorry. You must have noticed this and it was like screaming at the screen or something. But yes, indeed, this is the inverse, multiplicative inverse of x. So x, so if x satisfies this, then it is a unit. So all solutions of this equation are in this and are in the kernel of this or in this homomorphism, and that means the solutions of this equation, the solutions of n of x equals 1, is a subgroup of U, and we've just classified and we've specified exactly which subgroup and how to construct it. And so, wow, like just from considering from considering z adjoin root 2, we've been able to show that this is a subset of the units, and not only that, it's actually a subgroup of the units of z adjoin, so z root n, the ring z adjoin root n. So that's it for this video, and yeah, thanks for watching. I'm not sure exactly what the next video will be about, but I hope this made sense. So the idea of this, of course, is that we've just classified the solutions of the Pell equations of n root 2. Maybe in the next one, if we could find some explicit way to write this, for example, this may be not satisfactory. For example, what are the units? What are all the units? If we knew that, then this would more or less be very useful. Yeah, so we'll see you in the next video.